In this video, we're going to extend the FastUI application that we built in the previous video, and we're going to add a relational database behind the scenes that's going to store the data in the application. And we're going to use the SQLModel package in order to retrieve data from the database and also to insert new data into our database. And we're going to give users the ability to delete data from our application and also to delete data from the underlying database. So let's get started. So I have a GitHub repository here where I've pushed the code from the previous video, and that video was the introduction to FastUI. That should be appearing on the screen now, so you can clone this repository. And the code from the last video is in the starter directory, and after I finish this video I'm going to push the completed code to this repository as well. Now I'm going to open VS Code where I have already cloned that repository, and what we're going to do is, or what you should do is, clone the repository and create a Python virtual environment. And then you can install the requirements with the pip install -r requirements.txt command. That's going to install all of these requirements into a Python virtual environment. And I've updated these requirements. So for example, we're now using FastUI version 0.3 and Pydantic version 2.5.2. Now, once you've installed these requirements, what we're going to do is we're going to add a database to this project. We're going to go to main.py. And I'm going to have a quick look at what we did in the last video. So we had a user model, and that was just a Pydantic model that's coded into the application. We now want to persist that data into a database. So what we're going to do is create a database and create a table that can store these details for each user. And users have an ID, they have a name, and they have a date of birth. Now what we're going to use is a package called SQLModel. And this is a package that builds on top of both Pydantic and SQLAlchemy. And it allows you to define model classes that have all the power of Pydantic models and can also interface with databases. And because these model classes in SQLModel, if we go to GitHub, they actually inherit from the Pydantic base model. So these are very easy drop-in replacements in main.py. If we look at the API routes that we had that defined this FastUI application, many of these are taking advantage and using these Pydantic models. So by using SQLModel, we can quite seamlessly integrate the database functionality into this existing application. So let's get started just now. I'm going to expand the terminal here, and in the environment I'm going to run pip install, and we're going to install SQLModel. And while that's installing, what I'm going to do on the left hand side in the starter directory is create a new file, and I'm going to call this file db.py. And all of the setup code and the database models are going to be stored in this particular file for this small application. So at the top from SQLModel, I'm going to import a method, or a function, sorry, called createEngine. And this, as the name implies, it allows you to create an engine which will handle communication with the underlying database. Now in this video, I'm going to keep things simple, and we're going to use an SQLite database, which is a file-based database. It doesn't require any external installation, but these concepts should also work with databases like Postgres. So let's create a variable here, and we're going to call this SQLite URL. And we're using the SQLite protocol, and we're going to call this file that we're going to create for the database db.sqlite3. So like I said, SQLite is a file-based database. Once we have the name of the file, what we can do is create the engine, and I'm going to create a variable here called engine, and we can call that function createEngine that we imported. And you can see in VS Code what we need to provide to that is the URL, which is a connection URL to the database. So let's do that with the SQLite URL. And I'm going to pass a keyword argument here of echo equals true. And this will define the engine that we're going to use in order to communicate with the database. And we're going to read things from the database and write things to the database later in the video. Now what we need to do as well is create a model class in SQLModel that's going to encapsulate the data that we had for this user. So a user has an ID, a name, and a date of birth. Now what I'm going to do is actually comment this model out just now. We don't need the Pydantic model because we're going to create a SQLModel, which is a subclass of the base model that's going to represent this data anyway. So let's go back to db.py, and at the top from SQLModel, I'm going to import that SQLModel class, and let's also import field from SQLModel. Now you could split your models out into a models.py file or something similar, but we only have a single model, and this is a small demo, so let's just keep everything in this file. We're going to create a class called user. It's going to inherit from SQLModel, and we're going to pass table equals true into that. And inside the class we can define the fields that we need. So first of all we're going to define the ID, and we're using the type hinting in Python here. That's going to be an integer, and we're going to set that equal to a field because we need to specify the primary key equals true constraint here. So the ID is obviously going to be the primary key for this user table that we're going to create via this model. We also had a name field. That's very simple, it's just a string, and the date of birth is going to be an instance of a Python date. And of course we need to import the date object from the datetime module in Python, so we do that at the top here. And this is a very simple SQLModel class, and that's going to, under the hood, create a user table. So now that we've specified the engine for communicating with the database and also the model class, how do we actually go ahead and create this database and create the tables in the database? Now of course in a real application you want to use something like 𝗬𝗵𝗽 for migrations, but what we're going to do in this video is reference the documentation for SQLModel. And there's a function here, and this code is very similar by the way to what we've just written, so I'll leave a link to this below the video. But there's a statement here called SQLModel.metadata.createAll. So let's copy this statement here, and what we're going to do is paste that right at the bottom of the file, and we're passing the engine into that createAll function. And when this statement is executed, it's going to actually create the database. In other words, it's going to create this file here, and it's also going to create any tables that are registered with the SQLAlchemy metadata under the hood. In other words, any SQLModel class with table set to true. So let's now go over to the main.py file, and we're going to import the model class user, and we're also going to import the engine. So in main.py at the top here, I'm going to bring these imports in, and we can do that underneath the Pydantic imports. From the DB module, we're importing user and engine. And I'm now going to just remove the code that we had here for the user Pydantic model class. We don't need that anymore. Now, if we run this application, everything should still work as expected. And that's because we're still using this hard-coded list of data. This defines a list of user objects, the only difference being that user is now a SQLModel class, it's not just a Pydantic base model. But because we're using the hard-coded list and we're not actually saving any data to the database or reading things from a database, there is still no persistence in this application. What we're going to do now is we're going to take this hard-coded list of users, and we're going to use that to populate a database when the server first loads, when the application is started. And we can use a FastAPI lifespan event in order to do that. So let's go to the documentation for these events. A lifespan event allows you to define logic that should be executed before the application starts up. And that means that the code will be executed only once, and that's before the application, your FastAPI app, starts receiving requests. And you can also define code that's executed when the application is shutting down. Now if you scroll down on this page, we're going to see a little bit about how we define these events. First of all, we import from context_lib the async context manager. So I'm going to copy that and bring it into our main.py file. So let's do that right at the top. And then if we go back to the documentation, what we do is we define a function that's decorated with that async context manager. And you can define logic within that function that happens when the application starts. And then in this case, we have a yield statement. And anything after the yield statement is executed when the application is shutting down. So if you need to perform initialization actions, you can do it within one of these lifespan events before the yield statement, and any cleanup work can be done after the yield statement. So what I'm going to do is go back to VS Code, and we're going to define one of these functions just above the app object. So we need to decorate it with the async context manager decorator, and I'm going to define the function called lifespan, and it takes the FastAPI application as a parameter. Now in the body of this function, I'm going to pass the list of users. So let's cut that out of the main part of the application, and we're going to define that now inside of this lifespan event. What we're going to do with each one of these users is we're going to add them to the session and save them to the user table in the database. So how do we do that? At the top, from SQLModel, I'm going to import the session object. So from SQLModel, let's import the session, and we can then create a session, create a connection to the underlying database with a context manager here. So with session, and we pass engine into that, and we can give it a name, and I'm just going to call it session. We can now use this session to interact with the database. So what I'm going to do is loop over each user in the list of users. And for each one of them, we're going to first of all check to see whether that user already exists in the database. We can do that with a method on the session object, and that's the .get method. And this is SQLModel code here. Basically, when you call .get on the session, it's going to return an instance based on the primary key identifier. So we need to pass two parameters here. The first one is the SQLModel class, and that's the user class. So we're going to be looking up a user by its primary key, and the primary key is what's passed in as the second argument. So we have the user here, and we can reference its ID with user.id. So this is going to perform that lookup in the user table, and if the user exists, it's going to return that and store it in this variable, and we can check if that user does exist by looking at that variable. So we're going to check if the database user is not none, and if the user is not none, we can just continue because that user is already in the database. But if the user does not exist with this ID, the session.get method will return none, and we can then progress to below this if statement and add them to the database. We can do that by adding the user to the session. So let's add them to the session, and then after the for loop has completed, we can call session.commit, and that's what's actually going to affect the underlying database and add the new users to that user table. So that's the logic for when the FastAPI application starts up. We take this list of users, and then we open a connection to the database. We loop over each user in that list, and if the user exists already, then we just continue. Otherwise, we are going to add the user to the session and then commit that at the end of the for loop, and that's going to add all users that are not already in the table. The only other thing we're going to do here is just add a yield statement, and we don't need to perform any cleanup actions, so that's the end of the function. So everything before the yield statement is what's executed on startup. Now we need to perform one last action in order to get this working. We're going to copy the name of the function, which is lifespan, and we need to pass that into the FastAPI object when we're instantiating it and creating the application. So the FastAPI object takes a keyword argument of lifespan, so we can pass that function in there, and that's going to perform those actions on startup. So with all that set up out of the way, let's actually test this out. When we start the application using 𝗬𝗏𝗀, the imports are going to be brought in from the DB module, and this lifespan event function is going to be fired. And because we're looking at the db.py file, this function here is actually going to create the database, and it's going to create the user table, and then we're going to populate that table within this context manager here, and that's going to add the users from our hard-coded list into the database. So let's test this out now. I'm going to expand the terminal, and we're going to use 𝗬𝗏𝗀, which is in the requirements file, so you should have that installed, and we're going to look at main.py and the app object within that, and I'm going to pass the -- reload flag so that the 𝗬𝗏𝗀 server will restart whenever we make any changes. Now I have an error here, and that's because I'm not in the correct directory, so I'm going to stop this, and we're going to go to the starter directory and rerun the 𝗬𝗏𝗀 command. And that is now running, and you can see some SQL statements here being executed. So we have an insert into statement, and that's going to add users to the table, and we also have select statements that are looking up a user by its ID. So the select statement is what's being executed on line 27. When we use session.get, it's going to look up users by the ID passed in, and the insert statements are obviously coming from when we add the user to the session if they're not already in the database. Now just to verify that the users are in the table, I'm going to right click the database file and open that database. Now I'm using a SQLite extension for VS Code in order to do this. Once you've done that, you can look at the SQLite Explorer, and we can look at the user table, and we see that our 4 users are now part of this user database table. So the data has been entered successfully on this startup event. What we're now going to do is we're going to go on and we're going to amend the FastUI application to actually use the database data and to save new objects to the database. What we're now going to do is we're going to go to the page in the FastUI app that listed out all of the users. So let me scroll down here to the correct API route, and we'll fix these errors later on. These errors are coming from the fact that we've moved the users list. It's no longer part of the global scope, it's now part of the lifespan event function, so we'll fix that later on. This is the endpoint that lists out the users in a table in the FastUI application. Now the problem here is that, again, that user's reference to the list of users is no longer applicable. So what we're going to do is fetch the users from the database now. So let's just remove this comment to keep things concise, and we're going to create another session here. So with the session, and we pass the engine into that session, and we're going to call the variable session. So we're going to interact with the database here and get all of the users out of the users table. So let's create a variable called users, and we're going to call the session.exec method. And we're going to pass a SQLModel statement in here. We can use a select call, and we pass the model that we want to get back into that select function. And then once we've executed that statement, we can call .all, and that's going to give us back all of the rows from that table. Now we need to import select at the top, so let's scroll to the top here, and from SQLModel we're going to import select. Let's now go back to our function. Once we've fetched the users from the database, we can actually use them directly here in the data that we're passing to the table component. So no other changes are required here. We've grabbed all of the users from the database. These are SQLModel instances, and because these are subclasses of Pydantic's base model, this is just going to work in place. So that's very convenient, and it shows the interoperability of SQLModel and Pydantic. So let's test this out. If we go to the browser, when I go to this page, you can see we're getting the same data that we had before for these users. But this time that data is being pulled out of the database. It's not hard-coded into the application itself. Now we can see the select statement that's being executed in the terminal here. So I'm going to make this slightly bigger. And you can see in the logs here that we're selecting all of those columns from the user table. So the select statement is what's fetching this data for the users that's then being rendered in the table component. Now we can do exactly the same thing with the detail page. So I'm going to scroll down, and the detail page contains the information about a single user, and that uses a FastAPI path parameter. This has the user ID in the URL path, and that user ID is then used to look up that user. Now beforehand we were looking up the user from the list of users that was hard-coded into the application. This time we want to go to the database and we want to fetch the user from the table. So we need to change the logic for this, and we need to get a database session here. So I'm going to use that session object from SQLModel, and we'll call the object session here. And this time what we're going to do is we're going to try and fetch the user again by calling that session.get method that we saw in the lifespan event. So the session.get method takes the SQLModel class as the first argument, and the second argument is the value for the primary key for that particular table. So the value is now going to come from the URL here, and it's passed in here as a parameter to the function. So we can just pass that into session.get, and it's going to try and find a user by that ID. Now again, we can check just below the context manager, is the user none? So if user is none, what we're going to do in that case is, because we've not found a user with this ID, we're going to copy this HTTP exception here, and we're going to paste that into the if block. So if we don't find a user, we're going to raise an HTTP exception with the 404 status code and the message user not found. And again, that's actually all we need to do, so we can get rid of the try except block that we had before. And actually let's nest this over into the context manager. So what's going on here is we create a database session, we look up the user by the ID passed into the URL, and then if that user does not exist, we are raising that HTTP exception. Now if the user does exist, we progress to the return statement here, and the user is referenced here in the header text. We render out the user's name, and we also have the user being passed into a details component. So again, seamless integration here with SQLModel and with the underlying database. What we're going to do now is actually test this out. So I'm going to save this file, and we're going to go back to the browser here. This is the list page containing the table of all of the users. If we go to a single user, let's say John, we land on the detail page, and you can see all of the details for this particular user. And again, if we go back to VS Code and look at the terminal, you can see a select statement here for fetching that particular user. So unlike before, we have a where clause in this select statement where it's looking up the user by an ID that's passed in. Now there's one final page to fix in this application. We have these references to the users, and we moved that into the lifespan event. This is on the add user page. Now if we go back to the application and go back to the table here, we have a button that takes us to a page containing a form that allows us to add a user to the system. When we fill that form out, it's going to send the data to this endpoint that we defined in the last video. Now the logic for this was very simple before. We took that list of users and we appended the details for the new user. What we need to do now is, of course, actually save this user to our database. And this is better in many ways, because beforehand we were just adding it to a list in memory. And as soon as the 𝗬𝗏 server was restarted, the data would be lost and we would be back to the initial hard-coded data. What we're going to do now is save it to a database so that it's persisted, and the next time the application is started, it's still going to be there. So what I'm going to do again is we're going to create a session here. So I'm going to copy this context manager, and And it's worth noting that because we're using this many times, we can actually create what's called a FastAPI dependency. And if we do that, we can then inject the session into the handler function as a parameter, rather than writing this statement every single time. But just to keep things simple, I'm just going to copy paste it for now. Now, in order to actually save our new user to the database, we need to create an instance of this 𝗦𝗫𝗰𝗍, and then we need to add that to the session and commit that to the database. Now, we have some similar code here below. This was creating a user when that user was represented just by a normal Pydantic model. And with Pydantic, we had created a variable called ID, and we no longer need this, so we're going to get rid of that. And as well as the ID, we took the data that was submitted by the user, and that was coming in as this form parameter here, which was an instance of the user form Pydantic model. And we were calling model dump on that to pass those values into the user model. So we're going to keep this form.model dump statement around, and we're going to remove the ID. Now, we don't need the ID anymore, because if we go to db.py, the ID is a field on our database model, and it's got this primary key equals true keyword argument. So the database is going to automatically generate an ID. We no longer need to handle any of that logic ourselves. If we go back to main.py and we go back to this logic here, once we've created the user model, and that's a SQLModel instance, we can add it to the session with the session.add call. And then once we've added the user model to the session, we can commit that change to the database, and it's going to insert the new user into the table. And the final thing to do here, we can get rid of the append call, and we can just return the form response that's going to redirect the user in the FastUI application back to this page here. So let's now save this and go back to the application and try submitting this form. So we have a new user called John Doe. If we submit this, we can see that we actually get back that user in the table here. So the question is John Doe in the database? Let's go back to VS Code, and I'm going to use that tool here to inspect SQLite again. So let's open the database, and we're going to show that user table, and you can see we now have the user John Doe in this table. So by submitting that form, FastUI is sending the data to this endpoint. We then create a SQLModel user instance by dumping the data from the form and then adding that user to the session and committing that to the database. So this is all working fine. We've added a relational database to this FastUI application. Let's now show one final piece of functionality. We're going to add some new FastUI functionality, and we're going to actually add a delete user button to the detail page. So let's say we have the page for John. We want to have a delete user button appearing below this that allows us to actually remove John from the database. So let's go back to main.py here, and to start with, we're going to define a very simple Pydantic model. And I'm going to call this delete user form, and it's going to inherit from Pydantic's base model, and it's going to contain a single field, and that's the confirm field, which is going to be of type Boolean. Once we've done that, we're going to go back to the user profile function, which defines the detail page for a single user. And we're going to add some code to the components that are returned from this page. So below the user details here, we're going to add a button, and that button is going to be part of a form that, when it's confirmed, is going to try and delete the user from the database. So let's write this out now. We're going to create a div component, and that can take a list of subcomponents. Let's create a header here, so I'm going to copy the c.heading component and the text we want to pass into that. Let's pass a question here of delete user, and we can make this an h4 tag by changing the level to 4. Once we've defined the heading, I'm going to use a model form component, and we can parameterize those forms with a Pydantic model, and that's automatically going to infer the fields that are to be displayed on that form. So let's use that delete user form that had a single Boolean field, confirm, and then we can provide a submit URL to that model form. Now I'm going to use an f string here, and we're going to refer dynamically to the user ID here. So the submit URL is going to be /API/user, and then the user's ID, and then /delete. Now this user ID is coming from a path parameter in this endpoint, so we can reference that easily here in the component's submit URL. Now, as well as that, we can also pass some extra keyword arguments into this model form. We can pass class name in order to try and customize the style of the resulting form. So class name, we can use Bootstrap classes under the hood because FastUI has Bootstrap installed, or at least the front end components of FastUI can use Bootstrap. So we're going to use some Bootstrap classes here. I'm going to say text left, and we're going to specify that any buttons in this form should have the primary color, so button and button primary. And the last thing I want to do in these components is I want to pass some styles to the div itself. So after this list of components, we can pass the class name to the div itself. And what we're going to do here is we're going to define a Bootstrap card, and I'm going to give that some padding, and we're going to say column 4 so that it doesn't take up the whole page. Now this isn't going to look amazing, but it's going to show that you can customize the styles in a FastUI application. So let's save this file and go back to the page. And you can see that this is not looking particularly good at the moment. The button seems to have extended across the whole card almost, so I'm going to go back here and actually just remove these button classes from the model form. Let's try that again and go back here, and well, it looks a little bit better now, so my apologies for that. If we click confirm here and submit this form, what we want this to do is actually delete the user from the database. At the moment this is going to cause an error, and that's because we've specified an API submit URL here, but that doesn't actually exist in this FastUI application. So the very last thing to do in this video is define that API route. So what we're going to do is copy this route, and we're going to paste it down below in an app.post decorator. So we're using FastAPI's app.post, and we're pasting that same API URL. And then we can define the function here that's going to be called when we want to delete a user from the database. Now it's going to take the user ID from the path parameter, so that's going to be of type integer. And then we also need to pass an annotation in here. So I'm going to scroll up to the previous form that we had, and it was this here. I'm going to copy the signature for this. So let's copy that and go back down to our function and paste that in here. And I'm going to move this into new lines so that we can see it more clearly. So we take the user ID, and we're also taking the form. And we need to change the form instance here. It's not going to be the user form, it's going to be our new delete user form. And that's the Pydantic model class that we created here with that confirm field. Once we've got that, we can go back down to our function, and we can handle the logic for actually deleting that user from the database. Now we're going to need access to the session, so let's copy this session context manager, and we're going to paste that into our function. Again, we're using this in multiple places, so it would make sense to create a dependency here. Once we have the session, we're going to try and fetch the user from the database with the session.get function. That takes the user model and the user ID from the path parameter, and that's going to fetch that user from the database, or it will return none if it doesn't find a user with that ID. Now we only need to delete the user if it actually exists, so we're going to check if the user is not none. And if that's the case, we can call session.delete, and we can pass the user into that function, and then again call session.commit. So on this session object in SQLModel, as well as .get, we also have a .delete function that we can call if we need to delete a row from the database. Now the last thing to do in this function is return a response. So what I'm going to do is just go to the end of this function, and we're going to return a form response. And that's going to be a go-to event back to the home page of this application. So let's now test this out in the browser, and we're going to see if this works. We have the table of users here. If we want to delete one, let's say Jack, we can go to the detail page, and if we select confirm here and submit that, we are redirected back to the table page, but you can see that Jack is no longer in the table. And we can do this for the new user, John Doe, as well. So let's confirm that and delete John Doe. Now the question is, are these users being deleted from the underlying database? If we go back to VS Code, again I'm going to use this SQLite browser tool, and we can show the table, and we're down to only 3 users. So the 2 users that we did delete, they are actually removed from the database, and the logic within this delete user function is working. Now one caveat before we finish the video. Remember, we're using the 𝗬𝗃 server here with the reload flag. If we were to change anything in this file and save the file, you can see that the server restarted, and that's actually going to rerun this lifespan event here. And any users that you might have deleted from the application are going to be re-added. So for example, if we go back to the user table now after restarting that server, we don't have 3 users, we now have 4. Now, of course, in a real application, you wouldn't have a startup event like this, but that's just something to note. It doesn't mean that the logic is not working. It's just being refreshed on the startup event. So that's all for this video. In this video, we have taken our FastUI application and we've added SQLModel and a relational database to that. And that allows us to have an application that can actually fetch data from the database, and it allows us to add new users to the database via this button here and via the form. And finally, we've added functionality now to actually delete a user from the database. So when this form is submitted, it's going to remove the user from that database and redirect back to the table page. And the main takeaway from this video is how seamlessly that SQLModel can work with FastUI. It makes it very easy to build these kind of applications that are backed by a relational database. If you found this video useful, give it a thumbs up and subscribe to the channel if you've not already done so. And if you're enjoying this content, consider buying a coffee for the channel. There's a link in the description. And if you have any other suggestions for similar content, please let us know in the comments. Thanks again for watching, and we'll see you in the next video.